Welcome to part 2 of the video on the chain rule. In this video we're going to learn how to solve chain rule problems in a more effective way. So in the previous video we introduced the chain rule. The chain rule tells us what is the derivative of a composite function. So here we have a composite function h of x that equals f of g of x. That is the composition of the function f of g. In this case, the chain rule says that the derivative of h, that is h prime of x, equals the derivative of f, that is f prime, evaluated at g of x, times the derivative of g, evaluated at x. So let's consider again this example. H of x equals sine of x squared. There is another way of thinking about the chain rule. We can think of this composition of these two functions in another way. We can think of the function sine of x as the outer function. The outer function is the function f here. And we can consider the function x squared as the inner function. The inner function is always the function g. So what the chain rule tells us is that you should take the derivative of the outer function, that is f, and you evaluate it at the value of the inner function. In this case we get cosine of x squared, because the derivative of sine of x is cosine of x. But we must evaluate it at g of x, that in this case is x squared. So that's why we get cosine of x squared. And then we multiply that by the derivative of the inner function. Here we have the derivative of the outer function. And here the inner function, that is g of x, in this case is x squared. So its derivative is 2x. Here we have the derivative of the inner function. Let's see another example of how this can be applied. Here we have f of x equals 3 square root of sine of x. Here we can write this as, instead of square root, we can put sine of x to the 1/2. And here we can consider that sine of x is the inner function, and the square root, the function that takes the square root, is the outer function. So we think of the inner function as a variable. That's why here I'm going to replace the inner function, that is sine of x, I'm going to replace it by the letter y, that is another variable. So we apply the chain rule to find f prime of x, and we first take the derivative of the outer function with respect to y. The derivative of this function is 1/2 times y to the minus 1/2. And then I put a dot here because we must multiply by the derivative of the inner function. We say that the inner function is sine of x, but we use the letter y to represent the inner function, so here we put y prime. And here, replacing y for sine of x, we get this. Here we get 3/2 sine of x to the minus 1/2. Here we have y prime, that is the derivative of sine of x, and the derivative of sine of x is cosine of x. So we can write this as 3 cosine of x over 2. Here I forgot to put the 2 here, over 2 square root of sine of x. That's the answer. Let's see another example of this. Here we have f of x equals a square root of sine of 2x. As always, you can write square root of as elevating to the 1/2 power. And here we first, well, the outer function here is again the function that takes the square root. So to find the derivative of f, we take the derivative of the outer function, and we have the constant a here, and we have 1/2 times the inner function to the minus 1/2, and the inner function is sine of 2x. So we multiply this by the derivative of the inner function, and now we get this. But here we have the inner function is a composite function again. So to calculate this derivative, we must apply the chain rule again. In this inner function, the outer function is sine of x, so its derivative is cosine of 2x, evaluated at 2x, right? Because the inner function is 2x. And we must multiply this by the derivative of the inner function of this function, and the inner function is 2x, so its derivative is 2. We can cancel the 2 here with the 2 this over here, and we get that this equals a cosine of 2x over the square root of sine of 2x. That's the answer. So I recommend you to practice this, a lot. You should solve many problems involving the chain rule to get used to it. So that's all for now. Thank you for watching, and see you next time.